The volume of a spherical balloon is given by V is equal to 4/3 pi r cubed, where r is the radius of the balloon. The radius of the balloon changes with time. According to the rule, r is equal to 10 minus t. For what values of t is the rule r equals 10 minus t valid, and why? Well, I'm going to say between 0 and 10, and must be less than or equal to 10, as r cannot be negative. We can't have a negative value for the radius. We want to find v in terms of t. Well, v is 4/3 pi r cubed, so that's 4/3 pi, and then r is 10 minus t cubed. Find an expression for the rate with which the radius changes with time. In other words, we want to find dr dt, how the radius changes with time. So we just need to differentiate this, and that's going to give us -1. Find the exact value at which the volume is changing when t is 5 seconds. So we can differentiate this and evaluate when t is 5, but note that this is a calculator paper and it's just 2 marks, so there's no reason we can't do this on the calculator. So what are we doing? We're differentiating and evaluating when t is 5. So interactive, calculation, differential. My expression is going to be 4/3. Then we want pi. Let's put the 4/3 in a bracket actually. So 4/3. Pi then doesn't need to be. And then open a bracket, and we've got 10 minus t cubed. Our variable is t, and we want a first order, but we want the derivative at a value, and that value is 5. So OK that, and we get -314.2, and that's going to be in centimeters cubed per second. It's always worth checking whether you've answered a question properly. Note this says exact. I've given a decimal, so that's no good. I should have been in standard mode, but I can change it to -100 pi centimeters cubed per second. That's the answer I should give. Find the exact value of t when the rate at which the volume changes is -pi. So the rate at which the volume changes is dv dt. So after dv dt is equal to -pi. So action advanced solve. Then we need, the differentials are all in here, so let's grab this one, and we're going to differentiate with respect to t. And so in here we'll put in the 4/3 pi, open bracket, 10 minus t, that needs to be cubed, and then we need that to be equal to negative pi. And because we're solving for something that isn't x, we need to tell it that we're solving for t, and then execute. And we get 9.5 or 10.5, but we already know it can't be 10.5 from what we said earlier. So we're going to say t is equal to 9.5 seconds. Hence find the exact volume of the balloon when the rate at which the volume changes is negative pi. So we know the volume is 4/3 pi 10 minus t cubed, and we just found that t is 9.5. So that's going to be 4/3 pi 10 take away 9.5 cubed. So we just need to calculate that. So 4/3 pi multiplied by, that's going to be 0.5 cubed, and if we go to standard it will give it exact, and that's pi by 6. That will be in centimeters cubed.